Hello letters, here Mr. Gomez again, Mr. G, and we are going to be doing another question on vertical projectile motion. This question is activity 2 from the lesson 12, one of my lessons, okay? So, the question says the following position versus times graph shows the motion of an object dropped from a hot air balloon, which is ascending at a constant speed of 2 meters per second. The air resistance is ignored. So, let's quickly have a look to this equation. The following position versus time graph show the motion of an object dropped from a hot air balloon which is ascending at constant speed of 2 meters per second. So note the following. The object is being dropped, however, it is being moving up with the hot air balloon. So we have a hot air balloon. This is, imagine this is a hot air balloon. This hot air balloon is moving upward, and the object is being dropped from the hot air balloon. So this object is moving with the hot air balloon. Because of inertia, the object will also move up a little bit with the hot air balloon before it goes down to the ground level. It moves up a little bit. The object was moving initially with the same speed of the hot air balloon of 2 meters per second. That is the first important thing we need to know. The object is moving, still move up a little bit because it is moving with the hot air balloon before move downward. Okay, so at this point here in the graph represent the hot air balloon. We start in the graph from there. Okay, this is the position, the initial position of the object, which is the place where the hot air balloon when the object was dropped. The object moved first a little bit up until it reached the ground. This here, this 70,4 negative represent the final position, which is the ground level. This is ground level. Okay, the displacement of the object is going to be from the initial position to the final position. That is, that line is not straight. That is the displacement of the object from the beginning, from the starting point, the initial position, to the final position. That is the displacement. We can see that it's negative, therefore down was taken as negative and up was taken as positive in this question. Okay, so the object moved up a little bit first. It moved up a little bit because it is in the hot air balloon. As the balloon moving up, so does the object. Okay, so that is the first important thing here. So we understand what is going on in the question. So we understand the question. Now, question 2.1 says describe the motion of the object inward. Okay, I'm not going to write it down. We're just going to look here and describe, explain what is going on with the object. Initially, the object is moving with the hot air balloon upward with a speed of 2 meters per second. So the velocity of the object initially is 2 meters per second upward. That is the initial velocity of the hot air balloon. Let me write it not fully in word, but let's use symbols. Initial velocity is equal to 2 meters per second upwards because it is moving with the hot air balloon. Acceleration is constant and equal to minus 9,8. Let's not use the minus now, not yet. It's equal to 9,8 meters per second square downwards. I'm going to write down. How do I know it's constant? Because of the object is a projectile. So the only force is the gravitational force. So I hope that is clear, that part of the question. Question 2.2. Now, question 2.2, we have to do some calculations. Okay? So let's go to question 2.2. Now, this question says, calculate the time taken for the object to reach the ground. The time here, they ask for this time. We don't know that time, and we have to calculate it. So that time is the time the balls take to come from the starting point to the final point. That is what we need to calculate. How long does the object takes from the hot air balloon to the ground? Okay, so let's see what we have. Let's get the data of the object. What do we know? The initial velocity is equal to 2 meters per second. It's going to be positive because up is positive. Let's just write it here just in case somebody don't know. Okay, now the acceleration is equal to minus 9,8 meters per second square. Negative because it is downward, and we said up is positive. What else do we know? The displacement of the object is given and is minus 70,4 meters. Minus because it's downward. See here the vector showing down, minus 70,4. Okay, so this is the data and we're looking for the time. So from all this information we have, what will be the best formula that can help us to solve that question? What formula have all the information? Okay, for this one here, give us all the information. That one is the most suitable formula for this question. Okay, so let's first of all write the formula. The formula says that displacement is equal to initial velocity multiplied by the time plus half the acceleration multiplied the time square. Okay, and let's now substitute the values. Let's substitute the values. The displacement is minus 70,4. The initial velocity is 2. The time we're looking for it plus half minus 9,8 multiplied by the time square. Okay, so let's solve a little bit this one. Let's keep this one but solve this side here. So we have minus 70,4 is equal to 2 multiplied by delta time minus times positive minus 9,8 divided by 2 is 4,9 multiplied by the time square. Let's rearrange this. We have minus 4,9 time square plus 2 multiplied by the time minus, which is going to the other side positive, 70,4 is equal to 0. Now we have here a quadratic equation. In mathematics, you learn the following quadratic equation. You learn ax squared plus bx plus c is equal to 0. Here, this is a. This 2 is b, and the 70,4 is c. Alright? That is important to know. Now, how to solve for x is here. In mathematics, you learn that x is equal to minus b plus minus square root of b squared minus 4ac divided by 2a. All this is learned or was learned in mathematics, and you all do mathematics. So let's use that formula to calculate the time. Let's use the formula to calculate the time. Let's substitute. X is going to be delta t. Minus b is minus 2. Plus minus. So you have to do the calculation for plus and you have to do the calculation for the minus. B squared is 2 squared minus 4 that multiply a, which is minus 4,9 multiplied by c, which is 70,4. Alright, everything divided by 2a. So it's 2 multiplied by a, which is negative 4,9. Okay, so that is the formula you have to use to calculate time. And when you do the calculation, which you must do the calculation, you get two answers. You get time equal to minus 3,59 seconds, and the other answer is time equal to 4 seconds. Note the following: times cannot be negative, so this cannot be the answer. Therefore, the time is 4 seconds. That time, 4 seconds, is the time the ball or the object takes from the starting point up until here. So this one is going to be now 4 seconds. 4 seconds there. Okay? I hope you understand that one. Question 2.3. Draw the velocity versus times and acceleration versus time graph for the motion of the object. Okay? So let's draw the graph. This is question 2.3. All right. So now, graph of velocity versus time. This is not going to be at scale. It does not need to be at scale. Okay? Now this is velocity, meters per second. This is time in seconds. So let's start by writing down the data we have already. We know that the starting velocity, the initial velocity of the object is going to be 2 meters per second. Okay? That object is moving up to a 0. This is 0. And eventually it will pass the same point. So sometime when it passes in the same time will also be -2. But the object does not stop there. It goes further down. Okay? Now we don't know how long the ball takes to reach the maximum height. Okay? Remember, the ball, just for you to know, the ball does this. It's there and move up and it's going down to the ground. Here, the velocity at that point here, in this corner, the velocity is 2 meters per second. And the velocity here is also 2 meters per second. Okay? This here is the maximum height. Okay, sorry there. That is the maximum height, which is the velocity there is equal to 0. Okay, this is a positive, this is negative. Okay, so these two is the two I'm representing here, but the balls go continuous. The ground is somewhere down there. That is the ground. Okay, so let's calculate the time from the starting point to the maximum height. Let's calculate that time. Okay, so we can substitute it there. We know that the initial velocity is equal to 2 meters per second. We know that the final velocity is equal to 0 meters per second. We're talking about at maximum height. All right. We know that acceleration is equal to minus 9,8 meters per second square, and we're looking for the time. So what formula can we use to calculate this time here? From the data we have, you go to the formulas always, and then this one is going to help you to calculate the time, or the time it takes to reach the maximum height. Okay? So final velocity is equal to initial velocity plus acceleration multiplied by time. The final velocity is 0. The initial velocity is 2 plus minus 9,8 multiplied by time. If you rearrange, you get minus 2 divided by minus 9,8. That will give you the time to reach the maximum height. And when you do calculation, it will be 0,2 seconds. You can check the calculations, right? You can check the calculation. So the time to reach the maximum height is 0,2 seconds. Therefore, the time to be at the same point from which was thrown is also 0,2. 0,2. So 0,2 plus 0,2 is 0,4. Okay? So now here, the ball will do this one here. Right there. Ball will start at 2 and will do that. Now, this one is not the end of the object. Remember, the whole motion took 4 seconds. It took 4 seconds. So the object will continue moving for the entire 4 seconds in a straight line. This is a straight line up until there. Now we don't have the final velocity. This is the velocity of the object reaching the ground. So you don't have it, but we can calculate it. In fact, it will be a good practice to calculate it to know what is the final velocity of the object, to see the velocity of the object at which reaching the ground, okay? But it's not been asked. But we can quickly, it's a good practice. Now in that one, we can use the data, the initial velocity is equal to 2 meters per second. However, the force is positive. The final velocity, which is at which the velocity of the object reaching the ground, is unknown. The time is equal to 4 seconds. And we know that the acceleration is equal to minus 9.8 meters per second squared. So if you substitute, we can use the same formula as before. We have everything for that same formula. So we have that the final velocity is equal to initial velocity plus acceleration multiplied by time. Final velocity is equal to initial velocity, which is 2 plus minus 9.8 multiplied by 4. And the answer here, you can check the calculations, is a minus 37.2 meters per second. Remember the minus here, the minus there means that is down. That is the meaning of the minus. So the answer could be 37.2 meters per second down. Okay, so here in the graph, this number here will be then 37.2. This is minus 37.2, but it was not asked. So this is the graph from the starting point to the final point. I hope the question was clear. Next time we'll do another question on bouncing. Thank you very much. You can ask if you don't understand anything in this equation. Okay? Thank you very much.